almost getting to that point. God, you, Jalen,
Yes, sir.
look me dead in the eye. Look at me. Don't think it's funny. Look at me.
Off on it.
I'll tell you what, Jalen. You see that I wrote on the board?
That what was wrong with us?
No, below that.
Oh, call Jalen. Why do you want to call me?
Just know, however annoyed your parents are with you right now, let me. Angles and congruency. If you want to think it's funny, I'll throw you out of here right now so I don't have to deal with you.
Okay.
Write down what you need to write down here. Array. We've already talked about array. Shouldn't be anything hard. Somebody name me array in this picture. I heard a bunch of different things.
I like HS.
Are all of them correct?
Yeah.
Yeah. I heard HS, so let's not do that. Making sure that you're using the array symbol. What's that tell me when we name array HS?
You start at H, you go through S.
Start at H, go through S. Now I want you guys to help me out, just like you're doing right now. You're doing a fine job right now. I'm trying to record this. I've recorded it 3 times already, and all 3 of them have been horrible because my other classes didn't get through. We should get through about 20 problems on the homework. So we could help my friend here out a little bit and at least get some of it done right here while we're sitting here, right?
I'd probably lose my paper.
No, you won't. So HS. Making sure you use array symbol, 2 letters, 2 capital letters to name the array. We've done that. Are there other arrays in this picture?
Yeah.
Yeah, all kinds of. Remember, when you're naming an array, they call it an endpoint. Probably shouldn't be called an endpoint. It should actually be called a what? A starting point.
And
All right. So that because that's where you're starting at, and then the second letter tells you which direction you're going. If we use ray HS down here, let's put it in a blank down here. What's the opposite ray for ray HS?
That's a TN.
Agent.
We start where? To be an opposite ray, we have to start where? Same spot. So it's got to start at H, and then it goes which direction? Now, when we name it going out that way, what's the other letter that we use? We could use N.
Could use T.
Could we use T?
Yeah.
Yeah, HN tells us we start here and we go out through N. HT tells us we start here and we go out through T. Did I just do the same thing on both those? Yeah. So it didn't matter which letter the second letter was in that case. Opposite rays. What do we know about opposite rays? This is going to be important later on today.
Same starting point.
The same starting point, good. What else? They go out in both directions, right? Together they form a what?
Line.
A line. Or a
Straight.
straight angle.
180 degrees.
And it's 180 degrees. And that's going to be real important here in a couple minutes. Fill in what you need to fill in on this part.
Where is that? It's so flat.
It's good.
This is
Some of these you probably already know. At least 3 of those definitions up there you knew from the past. But whatever teacher you had to you or before probably told you wrong. Somebody tell me what's an acute angle?
Less than 90 degrees.
Smaller than 90 degrees. If you look, if Brandon looks at my posters up there, that's what they say also. That's wrong. An acute angle is an angle with measure between 0 and 90 degrees.
It's so small.
So what's that? But if you just say smaller than 90 degrees, what are you including in there that shouldn't be included in there?
Negative numbers.
Negative numbers. So like negative 10. If I tell you the measure of an angle is negative 10 degrees, is it an acute angle?
It's
No. It's a different kind of angle. So you gotta make sure that you know an acute angle is an angle with measure between 0 and 90. A right angle. A right angle is an angle with measure of 90 degrees. With a right angle, you might want to draw this for a right angle over here somewhere. Is that a right angle?
No.
No.
Not until you know for sure, right? What would they put in the picture to tell you that that's a right angle? That little box. All right, so maybe make sure you know that. An obtuse angle. In the past, again, what definition did some teacher tell you about obtuse angles?
larger than 90.
Bigger than 90. That's wrong. An obtuse angle isn't just bigger than 90, it's also what?
Smaller than 80.
Smaller than 180. It's got to be between 90 and 180. Straight angle we just talked about, it's 180 degrees. Degrees is the amount of turn. Some of you, and everybody all day long, has looked at me like I was stupid. Maybe your grandpas and stuff don't have this anymore. Maybe I'm just getting too old. Out in your barn or garage or something, grandpa's barn or garage, there's probably some round thing that looks like this and it's got a ray on it. And it starts with 0 up there. Anybody ever seen a thermometer? It looks like that, the round one. Thank you. All day long, or every other class. What?
It's like a clock.
Right.
Mr. Swihart has one.
Does he have one in there?
Classroom.
Yeah, we have one in our. Well,
See, that's why I'm annoyed today, because my other classes, I don't know what you're talking about. Hey, there's seen that looks like that. Like, are you-
we used to have one in our kitchen.
So you got this thermometer there. Thermometer starts at 0. All right, so if I'm the thermometer and I'm starting at 0, and what happens when the degrees, when the temperature goes up, the ray starts moving. And then it stops at whatever degrees it is. I got one in my barn and it stays like 110 degrees in there all the time. Drives me nuts. Even in the winter time, it's ridiculously hot in there most of the time. So, looks like this. Well, what's the hand doing? It's making an angle. It's turning. And that's where degrees come from. So temperatures in degrees, angles are also measured in that same degrees. The hands of my clock up here. If you look at them right now, together those two hands make a what? An obtuse angle. They make an obtuse angle right now. Could we figure out what that angle is?
Yeah.
How much is the whole clock?
180.
360.
360. So if the whole clock is 360, could we figure out how much it is between 12 and 1? What would you do?
Divide by 12.
So what's 360 divided by 12?
Calculator.
Oh, yeah.
Brandon's got one laying there, and he's letting it be lonely though. 360 divided by 12. The quicker we get through this, did I say this at the beginning? The quicker we get through, the more of your homework we get through.
Yeah.
30.
So, in between any two numbers on that clock is about 30 degrees. So looking right now, could we guess about what the angle is right there?
Yeah.
So from 11 to 12, how many degrees?
30.
And then from the 11 to the 1,
60.
60 to the 2, 90 to the 3, 120 to the 4, 120 plus 150. So that angle right now is about how many degrees? About 140, 150, somewhere around there.
That's pretty cool, ain't it?
149.
What's the angle, what would the angle be at like 3 o'clock?
Up to.
Oh, 90.
It'd be exactly 90. What other o'clock is going to be exactly 90? 9. Where, at what time would the hands be exactly 180 degrees?
Noon
Be
or
careful.
midnight?
12 and 6 o'clock.
12.
Only one of those.
Wait.
Oh, 6 o'clock.
6 o'clock when they'd be one straight up down. If it was noon or midnight, what degree would it be at?
Say sixes.
It'd be at 0 or 360, depending on what you're looking at. That wasn't even supposed to be part of this. Fill in what you need to fill in on this. Figured you guys were smarter than my other classes though, so go over all that extra stuff. We already talked about, no, we didn't talk about an angle. We were supposed to talk about an angle on the last one. I got sidetracked. An angle is a pair of rays with a common endpoint. Pair of rays with a common endpoint. I need that, I need this. This is my ray. J-E. I'll move in 1 second. Need somebody to volunteer for me, come up here and draw another ray that hooks to my ray and forms an angle. Go ahead, Jalen. To help Jalen out, where's he gonna start his ray at?
J. 40.
Any kind of angle does have to be.
Then, I don't want a straight angle. So he's gonna start it at J, go up that way, put a, I don't care. Now he's gonna put a letter on there, now be careful. You're gonna put the letter out there. Put some other point on there for us. Now put the letter there. Get rid of the other letter. This is, before we do it. That's, I'm not saying,
Oh, now look what you did.
$20.
doesn't hurt
Man,
Hurts me.
that hurt you.
Yeah. Oh, it's up.
Joe might have to press for it.
See sword.
So, first thing, common mistake here. I see a lot of people when they're drawing stuff, do we want that letter out there at that arrow? Because then you can't tell where it's at. So you want to make sure, and I know what Jalen did. He started to put the point there, and then he put the letter there, and then he put the arrow on there, and it just got everything confused. We want the points back in here somewhere. So we got this angle. What is that? Is that an F?
No, that was supposed to be the E.
We already got an E, so let's make it a
Oh,
D, right?
yeah.
So we got the letter D there. Name Jalen's ray for me. Ray JD. Name my ray for me. JE. Where they come together. That point, very, very important. You might want to circle that on your notes. Very important. It's called the vertex. You've got to be able to pick out the vertex of an angle to be able to name the angle and stuff. So my angle down here, the two sides are ray PK, ray PG, and the vertex, this right here, is point P. That's the vertex. That's where the two rays start and they go out. This part, anything in here, is called the interior of the angle. Anything out here is called the exterior of the angle. If I put some point way over here, off the board, is it on the interior or the exterior of the angle?
Interior.
Because what happens with the angle sides?
The line's going forever.
They keep going forever and ever and ever. Very good. They keep going forever. So sometimes you might have to use a little judgment there. before you start copying this down, Hayden, you with me?
Yes.
Before you start copying it down, listen closely. 3 different ways to name an angle. You can name the angle with one letter. It always has to be the vertex letter. You can name an angle with one number. That number will be given on the interior of the angle, close to the vertex. You can name an angle with 3 letters. That last way, with 3 letters, that's the way I would rather you use. Because if you start taking the easy way out and just naming it with 1 letter, it doesn't work all the time. The only one that works every time is naming it with 3 letters. Alright, sometimes the other ones won't work. By the end of the year, we'll probably name everything just about with the number that's inside the angle, because there'll be so many angles in the picture that it just makes it easier, and they'll put numbers in all of them. But sometimes they don't. So, when I'm naming an angle, this is the angle symbol. You got to make sure you don't get that angle symbol confused with what? Greater than or less than. So whenever I make a greater than or less than, see how both sides are sort of going diagonal?
Yep.
When I make the angle symbol, my bottom is always flat. So that I can tell the difference between the alligator mouth and the angle symbol. This symbol goes in the front. Every other symbol that we've done has went where in relationship to the letters? On top.
Yep.
This time it goes out in the front. So if we were going to name this angle with this, just that one point there, it has to be the vertex. It'd be angle P. If we were going to name it with the number, it'd be angle 1. The symbol out in front. Naming it with 3 letters, you do this. You start at one side and you walk around the angle. So angle, where did I start at? K. Went to what?
P.
Then I went to what? R or G. It's always 3 letters. You don't need both of these letters. So it's always 3 of them. K, P, R, K, P, G. Anybody have any other way that you think I could name that
RPK.
angle? Instead of going this route, how could I go?
Flip it around. RPK.
So R, PK would work.
GPK.
GPK would work. So on and so on. 3 letters, symbol out front. Notice what's always in the middle. The vertex has to be the middle letter every time. Go ahead and copy whatever down you need to copy down off that slide. Now again, I know Hayden's sitting over there. He's going to try to name everything angle P, angle R, angle Q. All the stuff that we do the rest of the day, you won't be able to name an angle with that one letter. If I draw this picture, how many angles in that picture?
4.
4 different angles. So if I put this letter right here, we'll call it N, and I say, that's the vertex, isn't it? If I say angle N, and I tell you to come up and point at angle N,
Which one?
you're not going to be able to do it, are you? You don't know if I'm talking about this angle, this angle, this angle, or this angle.
Just point out the point.
If you just point at the pointer, you're pointing at an angle.
No. Well, point it off for us.
So, when we have more than one angle in the picture, you can't name it with one letter. Alright? So, I don't even like this way. I like to, but books and everything else uses it. I'd rather we never ever use this method, because as soon as we do that, then Matt starts wanting to name everything with one letter because it's easier, and you don't never know what he's talking about. So this way or this way, 2 best ways. Name an angle. Symbol has to go out front, then either 3 letters or a number. On your paper there, what I want you to do, I think this is on your paper somewhere, isn't it?
Yeah.
You're going to answer 3 questions for me. Then I'm going to go around the room
What about angles and congruence notes 2 through 1?
That's just the title.
Rate these special.
We haven't done that
Oh,
one
well.
yet on this side. Right here. So you're gonna name 3 angles. You're gonna name 3 rays. And we're gonna go around the room and you're actually gonna give me your answers. And we're gonna name 3 vertices. Anybody have any idea what a vertice is? Plural of vertex. It's where they connect, right? So take a minute. First person with their hand up in the air, I'll let you answer whichever question you want. You just tell me which one, and we'll answer that. Then once we get down to the end, then if you haven't volunteered an answer, then you'll get one whatever's left. Go ahead, Josh. I'll sing yours first.
Number 2.
All right.
Ray DH.
Ray, say it one more time.
DH.
DH. Stop right there. That's all I want. It's just one answer. Everybody agree with Ray DH? Jonathan, next.
For number 3,
3.
D.
Point D. Everybody agree with that? That's a vertex. Next one, Brandon.
Ray BC.
Ray BC. Everybody agree with that? Now notice, I'm not even looking at the picture. If Brandon picked 2 letters on the picture, is there some ray that goes through those 2 letters? Yeah, it doesn't even matter. So could he have picked A and E? Is there some ray that goes from A through E? Yeah, it might not be shown on the picture, but it's there.
Wait, what? How is there a ray between those 2?
Well, it's not between it, but it starts at A and it goes through E. Even if it's not shown on the picture, is there some ray in our world that starts here and goes through there? Yeah,
How would you know if it's not?
because I just drew it.
I'm so confused.
So you could. Is there, if I pick A and F, is there a line that runs through A and F?
Why are you just making random lines?
Fact.
Is it okay to do it?
I guess.
Yeah.
I don't see a problem.
As long as we're not changing anything, there's something else that goes through there. All right, Thelma.
Neither did the number 1. 10.
Angle 10. Everybody agree with that? That's an angle?
Yeah.
Go ahead, John.
I'd say number 3B.
B. Everybody agree that that's a vertex of an angle?
Yeah. Does that mean anyone?
Go ahead, Aaron.
Ray FB, number 2.
Ray F. B.
Yeah.
Being serious now, Jalen, you understand that we can make the stuff as long as we're not changing something. We can't do something like, go from A to F out to here and make some angle and say that that angle's 20 degrees. But when I drew in this line, did I change the picture any? Not really. What do we know about any 2 points in our world?
Well, you did change it though.
No, but listen to what I'm saying. What do we know about any 2 points in our world? How many lines are there that connect these 2 points? 1. So no matter if I draw this line and then I tell you to come up and draw a line that connects those 2 points, how many different lines are we drawing?
A lot.
The same thing.
We're drawing the same thing over and over and over again. So we're not really changing anything. All right? Now if we do something like this, we say draw an angle in here, and then I tell you to come up and draw an angle, you might draw a different angle than me. But if we're just drawing this line that goes from A through F, everybody in here is going to draw the same line. It's not going to change. Josh, I haven't picked you yet.
Number 1. 8.
So angle 8.
Yeah.
Everybody agree with that? Madison. You with us? Give me one of your answers. C. Everybody agree that that's a vertice? Matt, give me something.
Um,
There's only one left, Matt.
Yeah.
Gotta pick an angle.
Angle. I chose.
Q angle right here.
ABF.
Yeah, I chose the Q.
You said angle ABF though? Is that what you said?
Yeah.
A,
I figured the count with that.
ABF. Does everybody agree that that's an angle?
mhm.
Let's go back to, who was this, Thelma? Thelma gave us angle 10. What if I told Thelma, nope, you can't name it with a number? Could we name that same angle some other way?
Angle CCH.
Angle CDH. Could we name it some other way?
HDC.
HDC. Could we name all these angles 2 or 3 different ways?
Yeah.
Now, that doesn't affect you so much. Who does that affect?
You.
When I go to grade stuff for you, I gotta know all the different names of that one angle, right? Now, the way it does affect you is it confuses you because you name the angle and you think, oh my God, and then you get all confused. Fill in what you need to fill in on this. We'll fill in the blanks here in a second, and we'll watch this little short video in just a minute.
I love video.
Daggone it, Hayden, I forgot and left you out. I'll make sure you have to answer 2 questions next time, all right? Will that make you happy?
Can I just rush real quick?
Yeah, hurry.
That'd be made out of cardboard or
You think?
looks like it.
Wish
Yeah,
you,
it's cardboard.
wish you were paying attention that much when I asked you what question you were gonna do up here. Angles are measured in degrees. We already talked about that. Last chapter, we talked about congruent segments. When you had congruent segments, what'd that tell you? What did it mean if segments were congruent?
Same measure.
Equal, same measure. What do you think congruent angles are? Equal, same measure. All right? An angle bisector. Last chapter we talked about a segment bisector. What does segment bisector do to a segment?
Sections
So
of
it's
Split it into 2 equal parts, right? 2 equal parts. So what do you think an angle bisector does? 2 equal angles. So looking down here at this picture, somebody name this ray for me. Put that right here on this blank. Ray BA. Ray BA is angle bisector of
LBZ.
which angle?
LBZ.
So if I write this, LBZ, is that going to be correct?
You need that little symbol.
Need the little symbol. What are you going to also make sure you do when you're writing this?
Make sure the
What's going to
Word
confuse? That's true, but what's going to confuse some people when you're writing that? The angle and the L. They're probably, for some of you writing, if I walked around right now, does that angle symbol and that L look the same?
So I just did it the other way.
So you got to make sure that you're not confusing yourself. I've seen some of your writing before, and you write like this. All of a sudden, then you look away from it and you think, what? LLBZ, what? And you don't know what you wrote. If I can't read if you can't read your writing, Ebersole for sure can't read it. So make sure, in a picture, on your picture, write this down. If I know these 2 angles are congruent, the way we show it in the picture is by marking them the same. And we put like little arcs in them. So just something like that would tell you that this angle and this angle are the same, are congruent, or equal. So that marking tells us that those 2 angles are equal. Brandon wants to be cool or something, and he's got some gang sign that he likes throwing up. Maybe it looks something like this. Who knows? He wants to put that on there. I don't care. As long as they're marked the same, that tells us that they're equal. You and your cat are in a gang.
It's not my cat.
It's a dog.
I hate my dogs. Like me.
Untouch it.
Which two angles are congruent here? Somebody name one of the angles for me.
LBA.
LBA, I heard. Somebody name the other angle.
ZBA.
ZBA. Again, what had to be the middle letter?
B.
The vertex. The B.
That's the big one.
All right? What this video is going to explain, it's going to explain how to use a protractor. And I'm just going to go over this real quick. This is one of my protractors I use up here on the board. If I'm measuring this angle, first thing I'm doing is I look at this angle. What kind of angle is this?
Acute.
It's an acute. So I know that when I look at my protractor and it's got two sets of numbers on it, which set of numbers do I use?
The smaller set.
Since it's an acute angle, it's going to be the smaller angle. And what the guy on the video is going to tell you, he's going to say match up the vertex of the angle with the hole in the protractor. Match up this side, one of the sides of the angle with 0, and then you come out here. This angle that I drew looks like it's at 50 or 130. So what's the measure of this angle, 50 or 130? It's got to be the 50-degree angle. It can't be the 130. Now he's going to tell you, oh, if you're going out to the right, then use this set of numbers. If you're going out to the left, use this set of numbers. And ain't a one of you going to remember that. Okay? Look at the angle first. Know if it's an acute angle, obtuse. Then decide which angle or which kind of angle you're dealing with. Which set of numbers you're dealing with. Somebody do me a favor and hop up there and turn the lights off for me.
What the?
Using a protractor.
Watch closely so you understand.
The protractor has two scales that run from 0 to 180 on the outer line. Two scales that run from 0 to 1.
Did I mention that we're going to have a quiz next class?
No.
Oh, so now I'm telling you.
Bet.
Thank you.
Using a protractor. The protractor has two scales that run from 0 to 180 on the outer line and 180 to 0 on the inner line. To measure an angle, line up the center of the protractor on the vertex of the angle. Make sure you align one side of the angle with the 0. Since the angle is aligned with the 0 on the inner scale, look to see where the angle intersects this scale. It intersects at the number 50, so the angle measures 50 degrees.
What other number did it intersect if it was at 50?
130.
130, right?
How do you know?
But how did he know to use the 50 and not the 130?
Common
Smaller.
sense.
It's small.
The acute angle.
If the angle opens the other way, you will measure the angle using the outer scale. Since the angle is aligned with the 0 on the outer scale, look to see where the angle intersects this scale. It intersects at the number 70, so the angle measures 70 degrees.
Cool.
You can also use the protractor to draw an angle. Start by using the bottom of your protractor as a straight edge to draw the base of your angle. Mark the angle vertex with a dark point. Now align that point with the center of the protractor, making sure that the line you drew lines up with the 0 degree mark. Without moving the protractor, draw a point at the desired measurement of your angle. Finish up by using the straight edge of your protractor to draw the remaining ray from the vertex on your baseline through the measured point.
Think you can handle all that?
Yeah.
Yeah.
It was a little quick.
Yes.
We'll go back over some of it. I'm not gonna ask you on the homework to measure 15 angles or nothing and not know how to do it. Fill in what you need to fill in on this. Now we're to the hard stuff. So now Jalen might have to start paying attention.
I have.
Jalen,
What?
why are you so defensive all the time, man? You know, have I not been saying that same stuff to everybody else in the room the whole year?
Oh, well, I wasn't here the whole year.
Still with me, Hayden?
Yeah.
You writing this?
Yes.
No, you're not. Your pencil's laying on your desk. Quit lying to me. Come on, Hayden. I never thought you would lie to me.
No,
See, Jalen, see how that works?
See how what works?
I'm messing with Hayden, and he's not getting all defensive about it.
Yep, let's not get it.
Deep breaths, Mr. Ebersole.
Yeah.
If I were to act like him, I'd totally be in trouble.
Adjacent angles. With adjacent angles. Sorry, I'll move this here in just a second. Write this in under adjacent angles for me. Nothing
Brothers.
close.
Oh.
Mathematical. Knowing that angles are adjacent angles tells you nothing about the measure or anything else of the angles. Does anybody know what the word adjacent means?
Is this math class that I have?
Yep. Does anybody know what the word adjacent means?
Heard it too many times, but I don't remember.
They share a side vertex.
Well, other than math, what's it mean in the real world?
Oh,
Oh,
they
you're
partner,
Jason.
Brothers.
or neighbors.
What's it in the real
Beside
world?
each other?
Beside each other.
Yeah,
That's
me
all
and
it
John
is.
are adjacent.
Oh, did you say that, John? I didn't hear it.
No, Aaron said
Oh, did you? Yeah, so you, like you and John are adjacent, all right? Whose room is adjacent to mine?
Miss
Jackie Barnes.
Mrs. Barnes. Notice we share a what?
Wall.
A wall, just like they share a
wall.
side, we share a wall, all right? Adjacent, hooked to, neighbors. But it tells us nothing mathematical. It doesn't tell us that the angles, you know, are the same. It doesn't tell us that the angles add up to 90. It doesn't tell us any of that stuff. A linear pair. A linear pair are adjacent angles, so neighbors, that together form a straight angle. What's it mean? Give me a number for straight angle.
90.
0.
180.
90.
180 degrees. Straight angle's 180 degrees. Vertical angles, and this is probably the most important of all of them. These two right here. This last thing is the first theorem of the year. This is a theorem. And this theorem says vertical angles are congruent. You'll probably never ever see me write it out that way again, because I'll always abbreviate it down to this. Vertical angles are congruent. We're going to make it as short as we possibly can. Chapter 1. We had to draw some pictures there way back at the beginning of chapter 1.
I remember that.
And nobody liked them because it was hard to draw the pictures. You had to read what it said and then draw it, right? Somebody tell me, how can I draw this? What am I going to start off drawing?
You gotta draw
A
two.
line.
One line, then what else?
An X.
Then another line. And they have to do what? Intersect. How many angles are formed when you do this?
4.
Draw this picture there on your paper. And number these angles. 1, 2, 3, 4.
I couldn't see, so I was waiting.
Oh, come on. Vertical angles are two non-adjacent angles. In this picture, which angles are non-adjacent?
1 and 3.
1 and 3. Does everybody agree with that?
Yeah.
Yes.
They're not neighbors. So angle 1 has to be congruent to angle 3. They're a pair of vertical angles. What's another pair of vertical angles in this picture? Angle 2 has to be congruent to angle 4. So if I told you angle 1 was 60 degrees, what could you tell me about angle 3?
60 degrees.
It's got to be 60 degrees.
Oh, let's see.
Let's go back up here to a linear pair. Linear pair, two adjacent angles that together form a straight angle or a line. You see any linear pairs in that picture? Give me an angle in that picture. Angle 1 and angle 2. Are they a linear pair? They form a line together?
Yeah.
Give me another linear pair.
2 and 3.
Angle 2 and angle 3 form a linear pair.
Angle 3 and 4.
Angle 3 and angle 4 form a linear pair.
Angle 1 and 4.
Angle 1 and 4 form a linear pair. I didn't write them all down because I don't have space.
Would 4 and 2?
But would 4 and 2 form a linear pair?
No, they're.
No, 4 and 2 are what? They're vertical angles. What do we know about a linear pair?
So line.
They add up to
180.
180. So if this angle's 60 and these two add up to 180, can we find this angle? How would we find it?
Subtraction.
180 minus 60. Somebody help me out.
120.
So what's angle 2 here?
60.
120.
120.
What's angle 4?
120 degrees.
Anytime I give you a picture and it looks like this for the rest of the year, I draw any picture with two lines crossing and I tell you this angle. How many of the other angles in this picture can you find?
All of them.
You should be able to find them all. No matter what the picture looks like, if you got two lines intersecting that way and you know one of the angles, you should be able to find the other three every single time. Linear pairs again add up to how much?
180.
180. Vertical angles, what do you know about them?
Equal.
They're equal to each other. Gotta know this stuff. Looking at this picture, name me a pair that's not on your paper there anywhere.
Name a what?
Name me a pair, a linear pair. Pick me an angle in this picture, it doesn't matter.
ABF.
ABF.
Nice.
Does everybody see this angle?
CBD.
We want an angle that with that angle makes a line, forms a linear pair, adds up to 180. Say it again.
CBE.
CBE.
What about CBD?
That angle, those two angles are actually what to each other? They're congruent. They're vertical angles, aren't they? We want one that forms a line with this.
What about CBD?
CBD. CBD. Close.
Crap.
Does that form a line? It's a little crooked, isn't it?
Oh, I got you.
What is it?
FBE.
FBE.
Yeah, look at that.
That's this one.
Follow it with ABC.
So we got this angle. We got this angle. Together, do they form a line?
Yeah.
Ew.
So what do we know about these two angles together?
180.
They add up to 180. Now let's do vertical angles. We picked ABF at first. Name me the angle that's vertical to ABF. CBE, that's this angle. I probably should trace it instead of that. Maybe this will help you guys out so you can see it better. If I trace it in a dark color,
Yeah, dark CBD's
can you see now how these two angles are vertical to each other?
Yes.
So if I told you that this angle was 70 degrees,
70.
you know that this whole thing over here is
70 degrees.
70 degrees.
So
Does that mean the angle 4 is 70 degrees?
No.
Does it mean angle 3 is 70 degrees?
Oh.
Means the whole thing, all of that together is 70 degrees.
So ABF would be congruent with CBE then.
ABF would be congruent to CBE. We could mark that way in that picture. What if I told you, let's get rid of that 70 there. What if I told you angle 4 was 20 degrees, angle 3 was 30 degrees?
Well,
What could you tell me about this angle over here? It's 50 degrees. What could you tell me about this angle up here? 130. How about this angle down here?
We figured them all out.
like said, the science kid. How'd you get that?
Fill this in. Look at your paper there and fill in the blanks. I'm going to be out of the way in 1 second. Not what I meant to do.
Man, time flies by.
Yeah. We gotta hurry. So fill in what you need to fill in there, picking, you're naming a pair of adjacent angles, you're naming a pair of a linear pair, and you're naming a pair of vertical angles.
Good.
I'm left-handed, so I can't do this.
Has anybody got a pair of adjacent angles yet?
6 and 9.
Angle 6, angle 9. Everybody agree with that?
Yes.
Can't agree with yourself.
I can say.
I agree.
6 and 9. So watch, let's trace it. Angle 6. Everybody agree that that's angle 6?
Yep.
Angle 9.
Ah, okay.
Are they adjacent?
6 and 10.
6 and 10. Angle 6, angle 10. Are they adjacent? Do they share sides?
7 and 8.
1 and 2.
No, 6 and 10 is right.
6 and 10 would work, wouldn't it? So angle 6, angle 10. Would angle 1 and angle 2 work? Are they adjacent?
Yes. Figure it out.
Yep, that would work.
7 and 8 would work.
7 and 8 would work.
Yes, they would.
Name a linear pair a little harder now. We
Well,
want two angles that together add up to how much?
180.
180.
Sorry, that would be 6 and 7.
6 and 7. So angle 6, that's there. Everybody see that angle?
Yep.
Angle 7. They add up to a straight angle? Are there others?
Yeah.
Yeah, I think Thelma said 1 and 2 for the adjacent angles. Well, 1 and 2 is also what kind of angles? A linear pair. Vertical angles. Vertical angles a little tougher.
6 and 8.
6 and 8. Angle 6, angle 8. Everybody agree with that? There's vertical angles?
Yep.
Name me angle 6 in a different way.
BDC,
BDC. Name me angle 8 in a different way.
EDG.
EDG. Got to make sure you can name them. You're not always going to be given those numbers. Name me an angle in this picture that you can name just using one letter.
B. Nope.
G.
D.
E. GDJ. B.
B? Yes, no, maybe?
No.
C.
No. I don't know.
A.
You know why you can't answer this question?
Because
You
there's
can't do
There
it.
is no angle in this picture that you can name with one letter. That's why I don't like that method of naming angles. Because if we, no matter what we pick, if I pick point B here, and I say angle B, do you know which angle I'm dealing with?
B.
All you know is where the vertex is. Get your books out. Books out, pages are open to page 71. We're going to do as much of this as we can. We got 18 minutes. We got to hurry, so hurry up and do it. Because I'm not going to wait. As soon as I see the first person ready to write, we're moving. Aaron wants to get as much done as possible so he doesn't have to do so much. This is part of your homework. We're going to do it together. Number one, if you're not writing it down, what kind of person are you?
Narcissist. I don't know. The bum.
I didn't say any of those answers, so for this recording, whoever's watching this, it was the students that said all those silly things, calling their peers
Is Aaron with me?
different names. Name the vertex of angle 1. Look at angle 1. Name the vertex. I know the vertex is going to be a point. What is it? Point what? Everybody agree with that?
Yeah.
That's answer number 1. Number 2, what's another name for angle 3? I know we're going to use the angle symbol. Everybody agree with ADC?
It says angle 4.
Oh, I'm sorry, it does say angle 4. Angle 4. My fault.
No, because 2 says name the sides. So actually you were right, reading out 3.
Oh, I was reading 3. My
You just
fault.
wrote out 2 and asked
Yeah.
the right question.
Number 2. I messed up. Name the sides of angle 4. Well, for the sides, I know we need 2 rays, correct? So give me one of the sides of angle 4. Be careful. CA. We need to start at C and go out through A, right? What's the other side? CD. Ray CD. I'll slow down and make sure that I'm not reading it wrong. What is another name for angle 3? Now we're on that one.
ADC.
Angle ADC. Everybody agree with that? What's another way it could be named?
CDA.
CDA. Going backwards. Number 4. What's another name for angle CAD?
1.
Angle 1. That will work.
Angle 1, you said?
Angle 1. Sorry, I'm trying to stay out of the way. We got the first 4. Number 5, they give you a picture, it looks something like this. On the directions, they say LF, ray LF, sorry, and ray LK are opposite rays. So what do we know about that? They form, how much is this whole thing right here? 180. LG, ray LG, that's this ray, bisects angle FLH. What's that tell us about these 2 angles? So let's mark them congruent. However you mark them, might be something like that, who knows? However you want to mark them so that you know that they're the same. The next thing says this. Watch closely so you understand this, because you're going to need it all year long. This is red. This
What's
little
the answer to
M.
number 5?
Say again.
What's the answer to number 5?
We haven't done it yet. This little M is measure. So that stands for measure. So this is red. Measure of angle FLG. Just know that that little M, that's all it means. Measure. Nothing hard about it. Measure of angle FLG is 14x plus 5. Well, FLG, that's this angle right here. I don't know how else to mark this. I just put a little arrow pointing in at it to help me out and say that that's 14x plus 5. Does that make sense to everybody? Then they tell us that the measure of angle HLG, that's this angle right here, is 17x minus 1. Thank you. What do we know about those two angles? They're congruent, they're equal.
They're
So,
equal.
so what are we gonna do with these two expressions?
Equal
14x.
5 equals 17x.
And we're gonna solve that. Solve it there on your paper. While I'm looking back at the book and seeing what they ask us to find. Anybody figure out what x is yet?
2.
Anybody else get 2?
Got 3.
Got 3?
Got 2.
2?
I got 2.
Maybe we need to work it out up here.
Right.
Subtract 14x on both sides, right?
Yep. Oh, there's a plus sign.
Those cancel out, that leaves us with 5 equals 3x minus 1. Add 1 to both sides. You're left with 6 equals 3x. What's the last step?
2.
Divide by 3x equals 2. How are we going to find the measure of angle FLH?
Add x.
FLH is right here. That's that whole thing together, isn't it?
Wait, you can take one of the,
You
you can take one of the,
protractors.
no, problems that we were given, plug in, and then times it by 2.
Okay, so where are we going to plug the 2 in at?
Either or.
So right here, 14 times 2 plus 5. What is 14 times 2 plus 5?
33.
Which one is it?
33.
33. So what's that tell us about this angle right here? 33. What's this angle over here?
33.
33. Well, we want the whole angle. 66. That's our answer. There you go, Hayden. That's the answer. Now, as we get into this a little farther, they're going to ask you to find like that angle. How could we find that
66,
angle?
0.
66 is the answer. No degrees.
Add 90, and then subtract from 180.
So add 90, because we know this is 90, plus these two, add all those up, and what should all of them add up to be?
180.
180. So we could find it that way. Next one, number 6. Number 6 in the directions. They tell us that these two are opposite rays again at the bottom. Ray BH, that's right here, bisects angle EBC. EBC. So that tells us this angle is congruent to, and you got to be careful here. Is it just congruent to this part right here? It's that one, right? So it's sort of hard to show it on the picture. Those two are congruent. Then they also tell us that BE, that's this ray, bisects angle ABF. So what do I know about these two smaller angles here?
They're equal.
They're equal. I don't know how we'll mark them. Maybe put 2 arcs in them or something to show that they're different than the other ones. Because we don't know all 4 of them are congruent. We know that these 2 are congruent. We know that the other 2 are congruent.
Do that like one line and draw
Do
2
that.
lines through it.
Do that line like that.
Yeah, the other ones draw 2 lines through.
Something like that maybe. Number 6, they tell us angle ABE. Angle ABE is this angle. And it's 2n plus 7. Angle EBF, that's this angle, is 4n minus 13. What do we know about those two angles?
Equal.
They're congruent, they're equal. So what equation can I set up?
2n plus 7.
Doesn't matter which order you set it up in. Somebody solve that for us. Tell me what n is here in a minute.
Ten.
10? Anybody else get 10?
Mm-hmm.
Brandon got 10, I could tell. Don't make me throw something at you, Brandon.
So that's the answer.
No, that's not the answer. What they ask us to find.
The measurement of the angle
ABE, angle ABE, which is this bottom angle. How are we gonna find it?
Plug in 10,
Plug in 10 right there. 2 times 10
27.
plus 7, which is 27 degrees. That's the answer, Hayden.
Wait. Is it not 15? Is it in 15?
I don't know, is it in 15?
Yeah, I got.
I'm confused because I did it in my head quick.
4 in
Are you
minus
sure you
13.
wrote down minus 13, not plus 13?
2 in plus
Oh,
7.
yeah, it's plus the
Yeah, plus 13 is 17 is 30. 30 divided by 2 is 15.
2 in,
So it's plus 7,
oops, that's
not
minus.
17.
Oh, it's plus 7?
Yeah.
Oh, okay, yeah, that might be why I got
That's
that.
what, that's exactly right.
Oh, yeah, it is plus 7. I gotta quit listening to you guys tell me 17 here, I'm writing down what you're saying. So it is 10, are we right?
Yeah.
Next one, number 7. Again, we know that this angle is congruent to, no, that's wrong. Your options, erase all. This angle is congruent to this angle, is that right?
Yeah.
And then this small angle is congruent to this small angle. My picture doesn't look right this time. EBH is 6x plus 12, EBH. EBH. That's from here to here, 6x plus 12. And HBC is 8x minus 10. So this angle is 8x minus 10. What do you know about those two angles? So set it up again. 6x plus 12 equals
8x minus 10.
8x minus 10. Somebody solve that for us real quick. Tell us what x is. Use all that energy, Madison.
It's 11.
Write it down.
11.
11. Anybody else get that?
Yeah.
And they ask us measure of angle EBH. EBH. That's this angle right here, right? So we plug in 11.
78.
78 degrees.
So the answer is 78.
Answer is 78, Hayden. Stop. Do that with some maturity.
About 6 minutes left.
Next one, this one's a little tougher. Number 8. Angle, the measure of angle ABF. ABF, that's this whole angle. Is 7B minus 24. Even the omni-intelligent Jalen's gonna have trouble here. He's gonna have to listen.
What you said.
7, we'll see. 7B minus 24 is that whole thing. Angle ABE, that's this angle, is 2B. We know that this angle and this angle were congruent from the directions, right? Can I set this equal to that?
No.
Doesn't work, does it?
Wait, you can set that times 2.
Ah, so if I know this is 2B, what's this gotta be?
2B.
Now what equation can I set up?
4B equals 7B minus.
And I'm gonna write it out. 2B plus 2B has to equal 7B minus 24. And if you don't have to write it all out, that's it, and you can put it together, that's fine. So that's 4B equals 7B minus 24. Solve that. Somebody, 8? Is that what you said? It's 8. Then they ask us to find measure of angle EBF.
It's 6.
Measure of angle EBF. Let's see, that's EBF. That's that angle. So it's 2 times 8, which you're telling me is what? You guys can handle that?
So the answer is 16.
Answer is 16
Degrees.
degrees.
Yeah, I can handle that.
That's the measure of angle EBF. 16 degrees. Matt, it's 16 degrees. All right? That's the measure of angle EBF. 16 degrees. Measure of angle EBF is 16 degrees.
Oh, I thought you said
I was
17.
thinking
17?
17.
No, 16 degrees.
Someone said 16.
What angle?
Number 9, they tell us the measure of angle EBC. EBC, that's this whole angle. From here all the way around to there is 31A minus 2. And they tell us the measure of angle EBH, it's this angle,
Pardon
is
teachers for the direction. At this time, we need junior class officers to materials room, please. Thank you.
4A plus 45. In the directions, they told us that this angle was congruent to this angle. But we can't set up this equal to this time. But if this is 4A plus 45, then that means this has to be 4A plus 45. Then we can say this angle plus this angle equals that whole thing. So 4A plus 45 plus 4A plus 45 has to equal 31A minus 2. And we solve that. Scoot this over a little bit because I'm running out of space going that way. That's 23A minus 2. Add 2 to both sides. 92 equals 23A. Divide both sides by 23. Grab your calculator. Type in 92 divided by 23. And it comes out to 4. And again, be careful because that's not what they ask us to find. They ask us to find the measure of angle HBC. HBC, that's this angle. So we're going to plug in 4 right there for A. So 4 times 4 plus 45. That's 16 plus 45, which is 61. So the answer to problem 9 is 61. Number 10. Measure of angle ABF. It's this angle. Is 8W minus 6. So the whole thing here, 8W minus 6. If you come up with a better way to label it, let me know. It's the best way I know. ABE, that's this angle. And we know these two angles are congruent. They told us that they were being bisected. So ABE is 2W plus 11. And part of that's in parentheses. Well, if this is 2W plus 11, then that means this one has to be 2 times W plus 11. If that helps you to shorten this up and distribute stuff out, then go ahead. That'd be 2W plus 22. And this would be 2W plus 22. And to make it even shorter, we could go ahead. We know we're going to add this one and that one together and set it equal to this one. So we could collect like terms right now and put in 4W plus 44 has to equal 8W minus 6. Solve that. All looks right. Then we divide both sides by 4. Just sort of checking it out because it didn't come out even and all the other problems come out even. 4 will go into 50, and let's see, 4 will go into 5 once. With 10, 4 will go in there twice. With 2, 4 will go in, and we add a decimal, so 12.5, W equals 12.5. And they said find the measure of angle EBF. EBF is this angle. So we're going to stick 12.5 in there, so 2 times 12.5 plus 22. 2 times 12.5 is 25, plus 22 is 47. So the measure of that angle is 47 degrees. Number 11, measure of angle EBC. EBC, that's from here to there. That whole thing is 3R plus 10. ABE, that's this angle. Oh, this one's completely different. So that angle is 2R minus 20. And they want us to find the measure of angle EBF. Well, the first thing, this angle plus this angle has to equal this straight angle, which is 180. So that's where we're going to get our equation at. So 3R plus 10 plus 2R minus 20 has to equal 180. Collect like terms, I get 5R, positive 10 and negative 20, give me a negative 10. Add 10 to both sides. You get 5R equals, those cancel out, 190. Divide both sides by 5. You can grab your calculator. R equals, let's see, 5 will go into 19 3 times. With 4 left over, 5 will go into 40 8 times. So R equals 38. They want us to find EBF. That's this angle. Well, they didn't tell us anything about that angle, but back at the beginning in the directions, they did tell us that this angle and this angle are congruent. So if this angle is 2R minus 20, then that means this angle has to be 2R minus 20. So 2 times 38 minus 20. 2 times 38 is 76 minus 20. That means that angle is 56. That angle is 56. We could find the other angles too, but that's all they asked us to find was that one. So the measure of angle EBF is 56 degrees. Number 12. We're using this same picture for 12, 13, and 14. Number 12 says, name 2 adjacent angles. Remember, adjacent just means they're neighbors. So we want angle something and angle something. 2 angles. And we could pick out just about anything here. If I pick this angle, MQN. And it's adjacent to angle MQS. That angle are adjacent. Whole bunch of different answers that you could have put on that. That's one possible answer. Number 13 says name 2 vertical angles. I'm going to pick one of those 2 angles that I just picked. MQS. So that's that angle right there. Vertical means that they're not neighbors, or not hooked, or they don't share a side. So if I look at that one, it's got to be this one over here. That angle, which is NQR, angle NQR. And 14 says find the measure of angle SUV. So I'm guessing that they told us something over here that I didn't put in my picture, and it was that angle right there is 58 degrees. SUV is this angle. That angle right there. Well, these two angles, that angle and this angle together make a straight angle. So they're a linear pair. So they got to add up to 180. So to find the SUV, I just take 180 minus 58. And that leaves me with 122 degrees. So that's the answer to 14. Problem 15, they give us a picture, it looks like this. This angle's 120. This angle's 2x minus 10. Notice that they put it in parentheses just so they can put that degrees on it. Sort of unnecessary as long as you remember that angles are measured in degrees. These two are vertical angles, so they have to be congruent to each other. So 2x minus 10 has to equal 120. We solve that equation. Divide by 2, you end up with x equals 65. Make sure you go back and read the problem. It says find the value of each variable. So this time, that's all we're looking for was x. Number 16, they give us a picture, it looks like this. This angle is 2x. This angle is 4x plus 108. Unlike this one, these two angles were across from each other, so they're vertical angles, so they were congruent. These two are neighbors, so they have to add up. These two are a linear pair, they have to add up to 180. So 2x, this angle, plus this angle, which that's a 108. Those two added together have to add up to equal 180. Like terms, that's 6x plus 108. Ignore that string mark. Subtract 108 on both sides. You end up with 6x equals 72. Divide by 6. Grab your calculator. 72 divided by 6. X equals 12. Again, all they wanted you to find was x, so you don't have to plug back in. So x equals 12. Number 17. They give us a picture, it looks like this. I'm not drawing the whole picture real well. They tell you that this angle is 2x plus 25. This angle is 3x minus 10. And this angle is y. They want us to find both variables, x and y. Well, we're going to have to find x first. These two angles we know are vertical angles, so this angle has to be congruent to that angle. So 3x minus 10 has to equal 2x plus 25. Subtract 2x on both sides. X minus 10 equals, those cancel out. 25, add 10. End up with x equals 35. That's part of our answer. The other part they wanted was to find y. To find y, what we're gonna have to do is plug back in here. So 2 times 35 is 70 plus 25. 70 plus 25, that's 95. So this angle is 95. That also means that this angle down here is 95 degrees. To find this angle, we know that this one and where y is, those two together add up to 180, so we just take 180 minus 95. And we end up with y equals 85. Number 18. Using that picture there on the side, it says refer to the figure, name the vertex of each angle. So angle 1, they want the vertex. Well, the vertex is going to be some point, so I'm going to write point. And if you find angle 1, the point that's at the vertex is just M. These should be pretty easy. Number 19, angle 2, the vertex of angle 2. Point R. Number 20, vertex of angle 4. Again, the vertex is just some point. This time it's point Q. Number 21, angle 7. The vertex is just point P. Problem 22 says, 22 through 25 says, name the sides of the angle. And it says use the picture. You really don't need the picture to name the sides of the angle, because if they tell you it's angle QPT, the sides have to be 2 rays. And you know each ray's got to start at P, it's got to start at the vertex, and then it goes out in each direction. So one of them's got to be PQ, and one of them's got to be ray PT. If it helps you to use the picture, then use the picture. And some of them, like when they get down to angle 6, angle 3, you're going to have to. Next one, angle MNV. It's going to be ray NM and ray NV. '24 says angle 6, so you have to look over there, find angle 6, and look for the rays that form that angle, and it'd be ray NM again, and ray NR. Uh, 25 is angle 3. We could do ray, it's got to start at, the vertex is R, so ray RP. We could have said ray RT also, and ray RQ. Ignore that stray mark. '26. Use the figure to write another name for each angle, and there could be several different answers to each of these. I'm just going to give you one of them. Angle 9. So we go over there, we find angle 9. Another way to name it, remember the vertex has to be the middle letter. So angle S, R, M. 27, angle QPT. Without even looking at the picture, another way I could name it is just turning it around and naming it TPQ. A lot of you are probably looking at it and trying to use a number. Well, in that case, they didn't give you a number, so I can't name it a different way. That's the other way. Thought maybe they gave us a number. 28, same idea. They said angle MQS. Well, I could name it angle SQM. It's a different way to name it. And if you look over there, SQM, we could have also named it angle 4. And 29 says angle 5. Go over there, find angle 5. Many, many different ways to name angle 5. I'm going to name it angle TPN. Problem 30. They want us to use that same picture. It says a point on the interior of angle VRQ. So take your pencil, trace angle VRQ, and we want some point on the interior of that. You could use point P. You could also use point T. Either one of those would work. 31, a point on the exterior of angle MRT. So if you trace angle MRT in your book, take your pencil or your finger, whatever, trace angle MRT. And we want some point that's on the outside of that angle. Probably the easiest one is point Q. Point Q. Problem 34, just real quick, I'm going to do like one more of these, maybe two more. Might do 34 and 35. They give us this picture. Looks something like this. They tell us this is 2y plus 6. This is 3x. This is 8y minus 102. And they want us to say, find the value of each variable. On this one, I could set up that this plus this equals 180, but that puts two variables in the problem, so I probably don't want to set up that. Easiest thing to set up is I know that this and this are vertical angles, so they have to be congruent. So 2y plus 6 has to equal 8y minus 102. Subtract 2y on both sides. These cancel out. You're left with 6 equals 6y minus 102. Add 102 to both sides. 6y equals 108. Divide both sides by 6. I'm going to have to come up here and do a little math. 108 divided by 6. 6 will go into 10 once. 4, 8, 6 will go into 48, 8 times, comes out even, so y equals 18. Once we know y is 18, we can plug back into either one of these two. I'm probably not going to pick this one, because I don't know what 8 times 18 is, so I'll pick this one, 2 times 18 plus 6. 2 times 18 is 36, plus 6 is 42, so that angle is 42 degrees. That means this angle over here is 42 degrees. What I really care about is what this angle is. So I know that these two angles together have to add up to 180. So 3x plus the 42 should equal 180. Subtract 42 on both sides. We're left with 3x. Borrow here, 8, 3, 138. 3x equals 138. divide both sides by 3. I'm gonna come up here and do a little math again. 138 divided by 3. 3 will go into 13 4 times. It's 12. Subtract. 3 will go into 18 6 times. Comes out even. 46. So that's x equals 46. X equals 46 with the answer. And then y was 18. Number 35. My book, I can't read all my problems, so if you're looking at number 35, you could set up many different equations here. The one I'm gonna set up is 2y plus 50 plus the angle right below it, which is 5y minus 17. Those two together have to add up to 180. Collect like terms, I get 7y. 50 and a negative 17 give me 33 plus 33. That equals 180. Subtract 33. Those cancel out. 7y equals, borrow here, that's 7 for 147. Divide by 7. 7 will go into 14 twice. 7 will go into 7 once. So y equals 21. Now, again, part of my book I can't read because it's ripped up. I'm too lazy to go get a different book. But they tell us, if I look at this, this angle is 2y plus 50. Well, I know what y is, it's 21. So 2 times 21 plus 50, that's 42 plus 50, that's 92. So this angle right here is 92 degrees. I know that this angle, that 92 degree angle, and this angle have to add up to 180. So in this angle, they give us 7x minus 248. Well, this plus this has to equal 180. So that's the other equation I can set up. 7x minus 248 plus 92 equals 180. Ignore all those stray marks. That's 7x. Negative 248 and positive 92. Grab your calculator and do that. It's a negative 156. Add 156 to both sides. That's 6, 13, 336. Divide both sides by 7. And you might want to grab your calculator. I'm going to do it out longhand up here. 336 divided by 7. 4 times 7 is 28. Subtract there. 7 times 8 gives us 56. Comes out even, so x equals 48. And y was 21. Again, many different equations you could have set up on this problem. Those are the two I set up, partially because I couldn't read what was in my book for this one, but there's other things, other ways you could have done it. Regardless of how you done it, your two answers should have came up. Y equals 21 and x equals 48.